Welcome to today's webinar brought to you by Datavale, Pepperdata, and Cloudera. I'm Stephen Fagg, Director of Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, After Cloud Migration, Key Data Management Practices You Need to Rethink. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, if you would like a copy of the presentation, you can download a PDF from the Handouts tab on the console once the event is archived. And just for participating in today's event, you could win a $100 Amazon gift card. Now, to introduce our speakers for today, we have Michael Agarwal, Global Lead and Director at Cloud Databases at Datavale, Joel Stewart, Vice President of Customer Success at Pepperdata, and Trishant Rao, Director of Product Marketing at Cloudera. Now I'm going to pass the event over to Michael.
Thank you, Steve. Before I begin, today, thanks for attending. I think there's a lot going on in cloud, right? To understand the role in the cloud, first we have to understand what and how it changes our operations and management in the cloud. I want to quickly introduce myself. I'm the Director and Global Practice Leader for Cloud Databases at Datavale. I have more than 20 years of experience in IT. I have a few certifications. I worked at Hertz. I was leading the cloud adoption there. And then also I have done a lot of DBA work in past, Oracle, SQL Server, MySQL. And as you can tell from my smile, I go to dentist regularly. A little bit about Datavale. This is where I work. We have more than 80 years of experience in cloud overall. Mainly, when we started as a database experts, doing a lot of database work. But now in addition to database work, we also do cloud work. We are AWS Advanced Consulting Partner, as well as we are Microsoft Gold Partner. For today's topic, we're going to briefly go over the differences between an on-premise and cloud, and then we will look over what are the typical things a database management practice do on the cloud, and how the cloud will be a differentiator for you when it comes to operations and management. This slide is not new. You have seen this as a pitch as a survey. Sometimes you have seen infrastructure side, but I made this very specific to the database management and operations. As you can see, as you go from on-premise to infrastructure as a service to managed services, the responsibilities are changing, whether it comes to when you have all the hardware, the data center security, the server maintenance, when you recycle hardware, all that responsibilities start to shift to the cloud provider. Now, with the virtualization layer, if you are using a managed service, very likely the virtualization layer is covered by the cloud provider. In the case of operating system, the install will vary whether you're doing for example, if you're doing a EC2 on AWS or a VM on Azure, you request what you need, but the installation is done behind the scene for you. As you go through the list, you see that patching, database, software install upgrades, database backups, all that start to shift to the cloud provider, and a lot heavy lifting is done by the cloud provider. So what that means when you are a database administrator, or when you are leading the data management practice in your company. So going a little bit deeper into different database management functions. If you are installing databases, Oracle, MySQL, SQL Server, often you using a media or a command line or scripts, PowerShell or Bash scripts or Python scripts. In cloud, you might do things differently. You might use infrastructure as a code. There are some limitations with infrastructure as a code. That's where you will add on in your infrastructure as a code, Python or Bash scripts. You're not going to be using media as much. So there's a change there. In terms of backup and recovery, if you are on-premise in a data center, you might use database native tools or a third-party tools. The popular ones I work with, like Cloudera or Redgate, those are some popular ones I work with. But there are many more out there which will do database backup and recovery. In a cloud, if you are on EC2, AWS EC2 or Azure VM, it does not change that. But if you are using a managed service, it's as simple as enabling it. In some cases, it's depending on the cloud you use, the service you use, it may be provided to you by default. High availability and disaster recovery. When you are on the on-premise, you are very likely to use database native tooling. For example, SQL Server is its own way, or like always on, as a HADR tool, and Oracle has Golden Gate, and so on. Very likely to use those tools. DataGuard is another popular one. And there are many third-party tools out there. With the cloud, if you're using EC2 VM, not much change. You can still use those third-party products or database native tools. But as soon as you go to managed services or a platform as a service, then in that case, in some cases you just enable it. In some cases, provided by default, you don't have to do anything. Performance and monitoring and database tuning. So this is pretty expert area. Most of the smart DBAs I work with, they take time. They have skills and experience to get to the performance tuning. It comes with a lot of experience. When you're going from on-premise to cloud, you might be using slightly different tools. Your observability tools might be changing, but the concepts, the troubleshooting, all that stays same. And I think this is where a database expert shines, and this their expert area. Security and compliance. When you're on-premise, you have more surface area to protect, simply because when you go into the cloud, you may not have operating system. So you don't have to worry about operating system patching or benchmarking or any penetration testing for OS. You don't have to worry about that. In addition to that, there are many other areas beyond databases which allow cloud to be more secure, and you have less area to protect. For example, if you're putting ALBs in the public subnet, the ALB doesn't, you don't have to worry about the operating system behind it. It's managed service, for example, and you have less surface area to protect. The user management stays same. Capacity planning. I remember when I was doing capacity planning on-premise, we will do benchmarking, we will do SQL IO to look at the IOPS, we will sometimes capture the transactions, run through to make sure we find their hardware. And this reason is it's a whole purchasing cycle, PO and shipping and assembling and putting on a rack. And all that takes a month to do, and you don't want to be wrong. You don't want to either, under provision, over provision. With cloud, you can start with, a good guess, a more simple way. If you can do quick benchmarking, half an hour, you have an idea. That's good enough to start. And the idea is you can change as the workload changes. You can change and adjust because those resources are available to you at your fingertips, or as simple as changing your infrastructure as a code, whether using Ansible, Terraform, CloudFormation, or as a resource template. Agility. This is, I think, one of the benefits of cloud. It allows you to experiment. I know a lot of organizations, they have an innovation team. They experiment with new ideas, new applications, and that means I want to be able to spin up. When I don't need it, I want to destroy because it's costing me money. But if it's successful, it will scale as adoption increase, and that's where compute, available compute and increasing compute as you need, and paying for what you use is allow you to be more agile and support your innovation ideas. Global replication. I remember doing global replication in a data center. It's very hard. First of all, you have to have another data center somewhere else in a different region, whether it's APAC, Europe, and then you have to set up networking. It's very close to setting up sometimes a second data center in a different region. And in addition to that, now you have to figure out, okay, how you're going to replicate, whether you're replicating, just one database, or whether you have a more active replication going on. It's very hard. In a cloud, there are concepts of global tables, global databases, which allow you to do that replication easily. For object level storage, you can copy data to other regions as well. So allow you to go globally very easy. And if you have infrastructure as a code, you can go do that in a less than an hour. Scaling, you are limited to what is available to you in terms of cores, memory. If you are using VMware hypervisor, depending on what resources available to you, sometimes they compete those resources. In cloud, that as easy to scale up and down as you need. Those hardware resources available to you, don't have to worry about not being available. The database design and development, that does not change. I think this is one of the expertise a lot of database management practices have, able to do the physical data design, logical data design, create data manipulation language statements, data definition language statements, and able to deploy. That doesn't change. Same with database deployment. I remember having outages when we were on-premise, whether there's network down or heating, cooling not proper, or we have an ice storm, not enough backup power, things like that. These clouds providers, they have much better budget, much better. They build a lot reliable data centers, and chances of having an outage there is less likely compared to a smaller data center provider. Similarly, you have more likely to have virtualization level problems compared to cloud. And the one feature I really like is the database version upgrades. You are responsible. Sometimes I remember pulling up the old media files trying to upgrade databases. In cloud, it's available to you. You can auto-enable in your maintenance window, and a lot easier to maintain. So going to the cloud is actually, as you can see, a lot more beneficial. It provides a lot of, and it changes. It just doesn't change the expertise you have, the skills you learn. It doesn't change anything. Nobody can take that away from you. But it does change the way you approach. It does change the responsibilities in some ways of what a database management team will do. With that, I think my presentation is over. I will turn over to Steve.
Thank you very much, Michael. At this point in time, I'd like to introduce our next speaker for today, Joel Stewart, Vice President of Customer Success at Pepper Data.
Thanks, Stephen. Hi, folks. It's my pleasure to be speaking with you today. I want to first start by elaborating a little bit on Pepperdata and our product, and then we'll go into some examples of what to consider as you have potentially performed a cloud migration and what to look for on consequential days, as well as go through a customer example. Pepperdata has been helping customers monitor and manage their big data applications and infrastructure. Unlike solutions that provide summary dashboards, infrastructure monitoring, and APM vendors, Pepperdata uses machine learning to scale system resources and provide a correlated understanding of applications across hundreds of real-time metrics. We work with some of the largest companies in the world and help them meet their SLAs, as well as track their resource spend, which becomes even more important in the cloud. So they have clear accountability across their different teams and infrastructure, both on-premise and in the cloud. And as we consider the cloud, I highly recommend to take one step back as you're looking at the status of your cloud migration and really think about your motivation of what brought you to the cloud in the first place. Understand what your objectives and goals were for migrating to the cloud. Make sure that you have a way to monitor these objectives and goals as you're going to the cloud so that you can be accountable for achieving the results that you're expecting to achieve, or understand if there is differences in what your expectations were, where those differences arise from. Other components that I strongly recommend is if you are planning a future migration, consider doing one in an incremental fashion. It gives you the most control, gives you the ability to learn about the progress of your migration early on before you make a big leap forward and realize you may have made a misstep or need to replan things as you go forward. But as we do look at what to do within the cloud, one of the biggest observations that we have and one of the biggest motivations I hear from our customers for moving to the cloud is around cost and around ease of deployment. So as you are looking at your cloud infrastructure after it's been deployed, you really want to make sure that you're understanding where your resources are being consumed, understand if you're sized appropriately for the applications that you're trying to perform in the cloud, that your infrastructure is sized appropriately as well, so you're not creating increased costs unnecessarily. The advantages of the ease of deployment that the cloud brings to us can be costly in some circumstances, but you want to make sure that that cost is appropriate. And one of the biggest ways to achieve this requires that we measure the activity of both our applications and the infrastructure that is running those applications within the cloud. So make sure that you're considering how you're going to monitor and understand the detailed usage of your cloud across all the different users and consumers, whether that is systems and infrastructure, or whether that's applications or teams of developers that may be building atop your cloud platform. And many customers find that there's some native solutions to some of these scaling concerns. For example, in the AWS world, particular for some of their services such as EMR, there are offerings for auto-scaling, and these can sound really attractive to customers. Because it's this promise of you're only consuming resources when there's demand for them. You're not over-investing in resources 24/7, where you're not actually consuming or running applications during that entire duration. You're really doing much more of a timeshare type focus for your applications. As they need more capacity, they're granted it, but as that capacity dwindles, because you don't have demand for it, you're saving money on the infrastructure itself. But in a practical case, we actually find that the auto-scaling that happens natively from these cloud providers is really aggressive, and aggressive in a way that can increase your spend very quickly, and then is a little bit slower to relieve that spend later on when the demand has been relinquished. So for example here, we're looking at the same workload in both these graphs. The top graph is showing us the results of auto-scaling natively, and the bottom graph is showing us the actual activity or workload that's happening on the cluster itself. As you can see in the top graph, auto-scaling happens in pretty large increments, and you kind of see this stair-step pattern. And then once it reaches its peak, it remains there for quite some time, approximately an hour duration at that peak in this example. And then it stair-steps down again toward the end. But as we compare that to the same time series on the bottom, and we look at the demand, we see that our demand is very much centered around the first 30 minutes of this application and then flattens out pretty quickly. And by the time our application is flattened out in terms of demand for resources, that's when the cluster has finally reached its peak in terms of capacity and spend. So we're not really able to utilize all that extra capacity because our demand has already been relieved. So this is something that's really important to understand how your applications are functioning and make sure that if you are going to spend on increased infrastructure and do so in any sort of automated way, that you're doing so appropriately for your actual workload. At the tail end of the application, we do see a little bit of additional demand, which is able to get completed very quickly because the cluster is very well sized at that point. But even if the cluster had been one stair step down and closer to about a third of the total size that it reached at its peak, we still would have been able to handle that demand, but we would have been able to save roughly 2/3 of our cost for that 1 hour where we were at the peak of the physical resources that are available. And what's most noteworthy to understand in this scenario is really being able to build this correlation between how the infrastructure is handling your application and your workloads, especially if you're using something as auto-scaling, relative to the actual demand that your applications are generating on that infrastructure, and make sure that they're aligned and that you're not staying at this peak unnecessarily for too long. And some of the, or I should say, the majority of our customers, of which we'll look at one, utilize a feature of the PepperData product called Capacity Optimizer that can augment the abilities of auto-scaling from some of the cloud vendors and make sure that that increase in capacity is actually happening at the appropriate times and is able to decrease the spend appropriately and quickly as well. In this particular example, we worked closely with a Fortune 1000 computer software company, and they had a pretty significant scale given their cloud infrastructure. They had over 10 distinct clusters working across different teams and workloads. They had millions of CPU hours per month in their total capacity within the cloud for these big data applications. And they really wanted to optimize their efficiency in the cloud, keeping their cost appropriate for the workload that they had and not overspending on the cloud. But they wanted to do that without having to sacrifice any of the SLAs or timeliness of their applications. They wanted to make sure that all those were able to perform and achieve results within the timeline that they're accustomed to. By using PepperData, we were actually able to work with them and augment their auto-scaling policy that they had in place to improve their cost efficiency by 35%. Over the 12-month period that we looked at for this particular study, their workload actually increased by 10% in terms of just growth and demand of new applications on the platform. But they were able to, while increasing the actual demand, spend about 30% less of vCPU hours to accomplish that same workload, or now growing workload, as I mentioned. And all these resources were able to get automatically re-provisioned and not have to spend any additional time or investment of people time to recoup these costs. These happen just by using the PepperData product directly on this environment. And then furthermore, they're able to get that detailed observability to make sure that their spend is appropriate relative to their workload of applications on the infrastructure as it's changing and is dynamically allocating different resource pools as needed. And while accomplishing the savings, we were still able to maintain over 99% of their SLAs. So they were not able to, or they were able to accomplish this without sacrificing any of those business needs that they had. So in conclusion, what I really want to stress is go back and focus on what your objectives were for migrating to the cloud. Make sure that you have the tools and understanding to be able to observe and measure the things that were your key objectives. If your objectives are to save money, make sure that you're understanding where you're investing that money and that you can understand which applications, which teams, which infrastructure costs are really contributing to your costs and the cloud budget overall. And then make sure that those are sized appropriately for the actual workload that you need. The optimization efforts that you see are also going to be dynamic. Your workloads are going to be dynamic, especially in a cloud environment. And so doing a tuning exercise as a project can be great, but then next week, next month, even the next day, you will see differences in your workload, in your underlying data set, and may need to go back and do that same project again. So instead of leveraging people time and investing in projects that are going to be recurring over and over again, I strongly advise leveraging automation to improve the efficiency. And the clouds provide some native tools, which are a great start, but there's a lot of augmentation that can be done to improve those tools even further. And so you really want to create and standardize on a practice of this automation within your environment to minimize waste and make sure that your data architecture and data infrastructure investment in the cloud is appropriately sized for the workloads that you're actually running there, and that you're not overspending on resources that your team is not using. And with that, I will hand things back over to Stephen.
Thank you very much, Joel. At this point in time, I'd like to pass the event over to our final speaker today, Sushant Rao, Director of Product Marketing at Cloudera.
Great. Thank you, Stephen. So hi, everyone. My name is Sushant Rao. I run platform product marketing at Cloudera, which means that I'm responsible for helping you understand what are the platform aspects, hybrid cloud, security and governance, as well as the full edge to AI data lifecycle. Let me explain what I mean by that. So one of the things we've seen in the evolution of architectures going from big data on-prem to cloud is that one of the key things has been a separation of compute and storage. If you know anything about big data on-prem, one of the kind of guiding tenets was that monocluster architecture where you had compute and storage on physical servers co-located. Cloud actually put that on its head and said, you know what, we can split out compute into its own layer using virtual machines. We put the data into an object storage layer, and it gives us a number of different things. It gives us agility, it gives us elasticity, you get isolation and transience, at least at the compute layer. But companies have done that, and they're like, something's not quite the same. What's different? And what's missing is context. In the monocluster architecture for big data is context. And you may wonder, like, what is context? So it's all your metadata, your metrics, your audit, your lineage, permissions, filters. And what people have found is like, I don't know where that goes when I move to a cloud-based cluster architecture. And what they're finding is that the cloud-based architecture works great for simple use cases. So it's single tenant, single workload, working with non-sensitive data and non-regulated use case. That doesn't give you everything that you need when you're trying to really move your workloads from your on-prem data clusters onto the cloud. So when you think about data lakes, there's a number of different things that they need. They need to separate compute, storage, and context. So context is identities, it's schema, it's policies, replication, information about workloads. You need to know all of that to provide discoverability, trust, compliance, reuse. And it's when you have that context, then you can go to multi-user, multi-workloads, being able to handle sensitive data and regulated use cases, along with long-running applications. So when you have an architecture that doesn't have context, you don't really have a solution, even if you have a cloud-native architecture, because it's not really matching your data architecture that you had on-prem. And that's what we need to address. So when you think about having a cloud-native data architecture, you really need to think about not only what happens to storage and compute, but also context. So in a cloud-native hybrid data architecture, you have your compute typically handled by virtual machines, but some places are now using containers. That is an ephemeral transient layer that can scale up and down as needed to handle the workloads. At the bottom, you have object storage, which is a really inexpensive way to store massive amounts of data. But what you need to kind of tie it all together is context, an always-on service that basically provides the foundation to ensure that your compute of your workloads and data matches your company policies. Now, what do I mean by that? Let's go move on a little bit more. So what does it mean to enable consistent data context? Well, when you think about a modern data lake, there's a number of different things that they need to provide. First is identity. How do you know the person is who they are, right? And well, corporations have that information, and you need to be able to make sure that the data lake is tied to the corporate identity so you can authenticate who this person is. Next is you have to make sure that you have different people in the organization that need to be able to access and share data sets. But how do you make sure that they are able to do that? Well, there's the schemas and making sure they have access to the data sets that are available, but also policy. Where do you go to ensure that you're protecting the sensitive data at a field and row level, right? So that means that you're able to ensure that all your data is protected by policy. Last thing is audit. How do you prove that you've been meeting regulatory requirements? So this is the audit and also lineage, right? Because you may have data that's been transformed and used in other contexts. So how do you make sure that you can audit that? And this is all needed when you're talking about privacy, compliance, and regulation. That also gets into active management. So when you talk about data lakes, one of the key things that you have to really think about is the ability to curate your data. So curation is not only defining who gets access to it, but be able to assign tags for easy discovery and also protect sensitive data. Replication, what happens to your metadata and lineage when you move data across environments? If you have your metadata and lineage on-prem and now you're moving that data set to a cloud-native architecture, right? How do you make sure you keep that metadata and lineage with it? Because you can't start all over again. Next is workload management. This is really about optimizing workloads. One of the challenges with elastic and transient compute is you can just address some of these workloads brute force. Just keep on bringing on additional instances to be able to process the data. Well, at a certain point, you start realizing that's starting to get expensive. Are we sure we've optimized our analytics to ensure that we're processing this data properly? And this is where you need to be able to really analyze the queries that you're running to really know, is this the most efficient use of the compute layer? Lastly, encryption. How do you make sure your data is protected not only at rest, but also in transit? And these are all the questions that you need to think about when you're thinking about running it in the cloud. How do you ensure that you have all these capabilities available when you move these data sets to the cloud? So the way we've addressed it is with something we call Shared Data Experience, or Cloudera SDX. It provides common security, governance, and metadata management from the edge to AI. So what does that mean? Well, first of all, let's start with security. How do you protect it? Protects sensitive data with consistent controls for both transient and recurrent workloads. The transient is really important because it processes data and disappears. So you don't have this idea of a cluster or a data set or workload being running forever. It comes, it goes, but you still need to make sure that it's protected during that time. Governance, because you need to make sure that when people have self-service access, how do you make sure that they are able to do what they need to do, but also ensure that they're doing it within the rules that you define? A catalog to provide easy access to data sets. The data lifecycle ensures that you have a single copy across all your analytics, that you're not having to create additional copies. And lastly, that this will simplify development and deployment. Yeah, SDX is what we kind of consider the foundation for Cloudera Data Platform. It's the world's first enterprise data cloud, which provides you a couple things. It's hybrid and multi-cloud, so you can run it in your data center and private cloud. You can run it on multiple public clouds, giving you a hybrid cloud environment. There's also analytics from the edge to AI. So it's the full suite of analytics you need to do your most interesting business use cases. So it's got streaming and ingest, ETL with data engineering, being able to run queries with data warehouse, operational database for mission critical applications, and machine learning to essentially provide prediction capabilities as well. It runs on Cloudera runtime, which is the open source heart of the entire platform. And lastly, there's control plane, a set of tools that will make it easier to manage and analyze your workloads. So what are the kinds of use cases that you can enable once you have these? So the first challenge that companies have is they're getting more data than they did last year and the year before. So you may be seeing this in your own environments where you're seeing more and more data from more sources. So how do you onboard those? Well, you got to examine the data as it comes in with automatic data profiling, right? To be able to categorize and characterize the data sets as they come in and put it into production as soon as possible. So you need to be able to discover the makeup of the data and be able to recognize sensitive data. And this is where the automatic data profiling comes in, to be able to understand like, oh, that column, that's social security numbers, or that's privately identified information. So once you can classify and characterize that data, what that means is you can now put attribute-based access controls to ensure that who is allowed to see the columns of the data and also at an attribute level. Once you have that, now you can think about multi-user data access. So we kind of think about this as, kind of the different lens that people in our organization need to have to be able to view the data. For example, HR and sales, they may have access to the same data sets. Say, for example, you may be looking at, kind of employee information, but they need different kinds of access to it. So, for example, HR may be able to see everything versus other groups may not. But even in HR, you may have to define it by people within it, right? Full-time employees may be able to see all the data in HR, but if you have an intern, maybe you don't want to give them all that access. And these are the kinds of questions that you have to think through when you give people access. So you have to see how is the data seen, and with that, you can use attribute-based access control. It's really crucial to be able to define at a policy level what are the attributes, the kind of policies at an attribute level. The next thing is being able to track the derived data usage, right? You may start off with ingesting data and transforming it, but there'll be tables, there'll be joins, the data is going to start from one thing and be combined with other data sets as people are starting to do interesting analytics. So how do you make sure that you have track what is going on with that data and make sure that those tags go all the way through? That's where data lineage comes in, right? Be able to take any table and say, show me how this data came into this table, right? What's the lineage of that data? Lastly, that comes into sticky data characterization, right? The tags that you use to classify it, all the way from when you first onboarded, go all the way through. So what that means is that you can always not only have the lineage of the data, but you can, even if it's been transformed, derived, you're keeping that all the way through, right? So it propagates all through those transformations. That leads to the next thing, which is safe data access, right? So once you have the attribute-based access controls and you have the policies in place, you can now dramatically increase the data, right? And who gets access to it. So because you have this classification propagation that goes along with data lineage, what that means is your access controls always are applicable and they're enforced. This gives you the consistent security and governance for all analytics and all deployments. Once you have that, you can radically increase the number of people that have access to your data. The other bonus achievement is that you get good governance, right? What that means is good governance means that you are in compliance with the rules and regulations, whether it's coming from a third-party entity or coming from a kind of your own internal rules and procedures. So industry regulations, data privacy, all of those are covered. So how do you get your user data used properly? Well, with consistent security and governance, you get increased business agility because you can get your data into your data lake faster and make it onboarded and in production sooner. You can increase business insights because your use cases can be used and deployed faster. And lastly, you get increased governance capabilities, right? So you can achieve and maintain regulatory compliance. What you also get is decreased operational costs because it's not manual, it's automated, right? Automated profiling of data as well as adding on additional users or groups without having to hire more admins. You can decrease the staff overhead, right? So you have one set of controls for everything. And lastly, you have decreased security risk because you have comprehensive controls for multi-user data access. So if you're interested in learning more, you can go to Cloudera Data Platform and learn more about SDX and how it enables you to have a full enterprise data cloud. And then you can also try it for yourself. We give free 30-day access to CDP, and you can try it for yourself. So with that, let me turn it over to Stephen.
Thank you very much, Sushant. At this point in time, we're going to dive into questions from our viewers today. First question is for Michael. Michael, can you give examples of how ETL work is different after migration to the cloud?
Yeah, definitely. So, if you think about ETL work, extract, transform, load, you're always dealing with some kind of source. A lot of times, sources are legacy systems like mainframe, DB2 possibly. It could be some kind of file share. Many places it could be. And then you, once you get the data from the source, you transform it, and then you have a destination. Transformation sometimes also mean cleansing, data quality, filtering out. There are just different use cases for it. In some cases, you actually build dimension model layer a little bit in ETL before it get to the dimension model in data warehouse. So it just depends. And then you have a destination where you put the data in. So how that changes with the cloud? There are tools, cloud-based tools like I'll give you some names: AWS Glue, Azure Data Factory, which are getting popular in their respective clouds as a ETL tool. For example, if I have using Glue, it will also crawl the data, create the data catalog for you, a lot of useful feature. Some organizations still have, SSIS and Informatica and other tools, simply because the sources, the source, it does have, in terms of able to connect to the source, it sometimes have a local connectors and a lot more bigger data set to connect to the source. So because of that, it allow you to connect to legacy sources, for example. But as you can tell, if the nature of the work doesn't change, the tools might change. A lot of organizations are using Lambda for ad hoc cleansing, transforming. They may be using S3 in AWS, for example, to retrieve the data and store in a more of a bucket, on a clear bucket. So things are a little bit slightly changing, but the knowledge of ETL doesn't change. It's just different, little bit different tool sets. And often destination is the cloud if you are in the cloud. So that's makes it easier because right there latency is low, and sometimes you have a direct connection with the tool you're using compared to finding a connector or something to connect to the destination. So that's kind of summary, and I think it depends on the specific situation, the tools, but that's kind of in general the differences.
Understood. Thanks for clarifying, Michael. Joel, our next question is for you. As organizations move to the cloud, are the roles of IT ops and developers different when it comes to budgeting, troubleshooting, and even deployment? Are new skill sets required to effectively manage cloud performance?
Thanks, Stephen. I would say yes, the roles do shift a little bit. In a traditional data center architecture that is owned by an organization, the role of IT is often more expansive and includes things like actually physically racking the servers, planning the infrastructure for power and networking, planning for things like high availability, disaster recovery. But in the world of the cloud, so much of that is now being put on the cloud vendor directly, and so that's no longer the responsibility of IT. IT's role shifts a little bit more into the software and architecture layer directly to kind of provide sponsorship and certification within an organization of what are the best tools that are going to be effective for their application developers and business to utilize within the cloud. The cloud has got so many different options that are available, and those change from cloud vendor to cloud vendor, but IT really becomes the selector and the architect of what is the ideal configuration in the cloud infrastructure instead of within the data center. For the developers, however, they don't have too much of a role that changes. They still develop their applications to be certified on the platforms that IT has provided for them. And with respect to budgeting, that changes organization to organization. Some organizations divide the budget by the functional groups within the team and are charging back their organizations by resources they consume within the cloud. Some organizations centralize that instead, and IT handles the budget of all the cloud spend centrally. So it really depends on what model is suitable for a customer organization, but we've seen both models work. And if there is a need to provide chargeback-like data, making sure that you're having the right tools that are available to you for being able to get that granular observation of who's consuming which resources can be very important.
Understood. Thanks, Joel. Shashank, our next question is for you. Why is attribute-based access to data important? What's the impact if we don't have it?
That's a good question. I think the best way to think about it is let's look at if you don't have it. Say you have a data set and two different groups in your organization need to want access to it, but there's sensitive information in there and one of the groups can't see it. So say there's column A, they can't see it, but they can see everything else. Whereas kind of the first group can see everything. Well, how do you give them access to that data set, but then ensure that the second group can't see column A? Well, without attribute for access control, the best way for you to do it is basically make a copy of the data, remove that column of data that the second group can't have access to. What that means is, well, now you've got another copy of the data, so you're taking up more storage. You now have more complexity because you now have a copy of the data, and you now have to kind of wonder about lineage and audit and things like that. And you're now running it on two different clusters. Okay, so now you have additional infrastructure costs from the compute layer as well. So that becomes problematic. But what if you had attribute access control? What if you could just set a policy that group A can see all of it, but group B, or the second group, can't see column A, right? Or can't see that first column. What it means is that you can now have multi-tenancy, one set of data running on one cluster, but what they can see and what they can do with the data is enforced by these attributes and the policies on those attributes. And that's the power. It's going to fundamentally make it easier for you to manage and dramatically reduce your costs from an infrastructure perspective to be able to use attribute-based access controls to that data.
Got it. Thanks, Shashank. Michael, we're circling back to you. The question is, what about data quality and data governance after migration to the cloud?
So first of all, the data quality, data governance, pretty close to my heart, simply because I have seen customers struggle with, they will generate nice dashboards, reports, but the data quality not there. And the decision makers who are looking at those reports, dashboards, they can't rely on data and so on. So it's very important to have good data quality, not having duplicates, having the correct format. For example, if you have zip code, 6-digit zip code is not going to help. When you start plotting, geoplotting, start looking at your reports on regional reports for your customers, for example. So data quality pretty important. How the cloud changes, I think it simplifies it simply because now you have a lot of event-driven tooling available to you where you can do preventive measures as well as more reactive measures. What I mean there is I can, for example, if I'm using AWS, I can invoke a Lambda function on every write if I want to, and then check the quality of it. Again, that's more reactive where I'm allowing the application to write a bad data which is not quality, and then I'm reacting and either notifying or fixing it, for example. So it does simplify in terms of tooling, in terms of options available to you, but the basic fundamentals of taking the ownership of the quality and the governance, making sure within an organization people understand the importance of that. I think that's the biggest undertaking because sometimes the organization don't take that seriously. So that's the bigger effort, I think, to me. I work for DataWhale. We have database management practice where we do look at not just database, but we look at overall the data governance, analytics, all aspects of the enterprise data management. The other part is governance. That's data stewardship, making sure not only who can modify the data, do they have the right information available to them as they are updating, modifying the data. Other part is who can access it, who can read, who can write. That part of sometimes data security or data governance. Again, I think the tools are changed where you may use bucket policies, for example, in S3 or Lake. For example, if you're on AWS, you might use a lake formation. Lake formation will allow you to create the data lake, but also enforce those permissions as you're creating those objects in your data lake. So tools are available, but I think the biggest thing is following those principles, making the importance. I think that's the biggest generally drawback, not necessarily, as I say, on-premise or cloud.
Understood. Thanks, Michael. Joel, this next question is for you. With fundamental shifts always occurring in the industry, for example, the shift from Hadoop to Kubernetes, how does an organization quickly adapt and create a strategy for those kinds of changes?
Thanks, Stephen. I think what's most important in this just kind of gets back to my presentation a little bit is understand what your goals are in terms of your organization and what you're trying to accomplish. In many cases, the adage of if it's not broken, don't try to fix it can be appropriate, and you don't necessarily need to be an early adopter of these technology shifts. But as you do notice these trends becoming more prevalent in the industry, it is an important thing to consider and stay on top of so that you don't get stuck on a technology that becomes obsolete or anything of that nature. But if you are looking to make a fundamental shift in your underlying architecture, really understand what the pros and cons of that are. For example, in the big data infrastructure space, Kubernetes can be a lot more transferable between different hardware sets, whereas technology is provided natively from some of the cloud providers like EMR or Dataproc for AWS and Google Cloud respectively. If you are trying to operate in multiple clouds, you're going to struggle to migrate between these two infrastructures, whereas if you use something like Kubernetes that's more unified, you'll be able to migrate and operate in both clouds more seamlessly. But if that sort of goal is not the same, or is not a goal for your organization to operate in multiple clouds or operate in the cloud and in your data center seamlessly for the same applications, maybe that's not something you need to really strive to adapt so quickly. So just be thoughtful about what the pros and cons are and what is the right timing for your business as that trend matures over time.
Understood. Thanks, Joel. Shushant, our next question is for you. I want to store all my data in a data lake. I can do that with most cloud vendors. What does Cloudera add that they don't?
It's a good question. I think a lot of times people think about, hey, if I just have it in object storage, I got a data lake, I'm all set. And I think the question to ask yourself is, okay, so then how do you make that data available? How do you provide the proper policies, security, governance to ensure that people are accessing data sets that they're allowed to see, but also even if multiple people or groups can access the same data set, maybe there's personally identifiable information or private information in there that not everyone can see. How do you make sure that your users and groups can see the data they're supposed to, but not violate compliance by accessing data that they're not? And this is where SDX comes in. It provides a consistent framework for providing essentially policy-based controls on your data so that you can ensure that as you scale out and you have more and more users and groups accessing data, that they're doing so based off policy, right? And that Group A can see the data they're supposed to see, Group B can see the data that they're supposed to see, down to the row level. The other aspect that this really becomes interesting is lineage, right? As you think about data being transformed, derived and used in other kind of analytics, how do you keep track of it all the way from the beginning all the way through to all these different use cases that you're going to be using with the data? And that's why having a consistent security framework that tracks your data from the time you ingest it all the way time to the point you archive it is really important, because this is going to be true regardless of what environment you're using. You may be doing it on-prem, you may be doing it in Azure, you may be doing it in AWS. You need to make sure that you can have the same policies and the same capabilities for security and governance across all of them. And that's what Cloudera's SDX provides you.
Understood. Thanks, Sushant. Well, it looks like we're just about at the top of the hour. It's really all the time we have for questions today. We apologize that we were unable to get to all of your questions, but as I stated earlier, all questions will be answered via email. I'd like to really thank our speakers today for coming here and sharing their insights. Michael Agarwal, Global Lead and Director, Cloud Databases at DataVale, Joel Stewart, Vice President of Customer Success at PepperData, and Sushant Rao, Director of Product Marketing at Cloudera. If you would like to review this presentation or send it to a colleague, you can use the same URL that you used for today's live event. It will be archived, and you will receive an email once that archive is posted. Plus, again, if you would like a copy of this presentation, you can download a PDF from the Handouts tab on the console once this is archived. And again, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on April 30th, and we will notify you by email if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.